for using sine law to find missing sides and angles, this is a kind of a perfect law that it allows us to find like angles and side lengths. What I really do enjoy about this guy is that it works for, you can put this here, works for any triangle. Okay. What I mean by that is whether it be a right triangle or like just an equilateral, scaling, whatever, it's going to work no matter what. We're going to get into like SOHCAHTOA later. And that guy strictly just works on right triangles. However, if you dislike SOHCAHTOA, you can pretty well use this guy for every right triangle that you want to deal with. So it does make life a little bit easier in that way. There's only one example where you kind of don't, but if you remember Pythag from grade 9, literally there is no actual need for you to ever have to be forced to use SOHCAHTOA. So what does this formula look like? Well, it looks like this. Okay, and there's a couple of things I'm going to add into this, right? So A over sine A is equal to B over sine B. There are 3 side lengths to a triangle. If you type this in online, you may see A over sine A is equal to B over sine B is equal to C over sine C. But we're really only going to be looking for like one side length at a time or one angle at a time. So let's just keep it like this and make it easier on ourselves. On the top is always the side length, okay? Right? It is denoted by lowercase, so you can put LC here, right? It's always denoted by a lowercase, whereas the bottom is always going to be the angle. And the letter for the angle is always going to be uppercase, okay? And again, more important than anything is that you know that you have to find a known pair in order for this to work. So the only time this will not work is when you cannot find a known pair and you'll have to go into cosine law. But those are, you'll see them in the long answer, but you might only have to do cosine law once, right? Whereas sine law, you'll be able to kind of get away with. So what do I mean by a known pair? What I mean is when I have an angle, we talked about this the other day, it has a relationship with this side length here, right? This angle has a relationship with that side length there. Because, I say this because if that side length, right, that angle got bigger, well then this side length would get bigger. They have a relationship with one another. So, all that to say, when I'm looking for a known pair, what I am looking for is, on a question that looks like this right here, let's just say he's 60, he's 5. This is what I am looking for, and that is 50 right there as an angle. The known pair in this case is the 60 and the 5. I have a side length that is opposite, I'll rephrase it. There is a known side length opposite a known angle. Okay? Known side length opposite a known angle. So just like we were looking at with similar triangles, now that I have this, I can find missing pieces. And I can use this formula. So what would that look like? Let's do the example right down here. Let's try it out. So if 60 goes with 5, then x is going to go with 50. Why? Because they are opposite of each other. So if that's the formula that I'm using, I know what my known pair should be. So it's going to be 5 over sine 60 is equal to x over sine 50. Now, What I want you to do on these guys here is to ensure as well, put like another little star right here. Ensure your calculator.
In degrees.
Yeah.
Don't want to be in radians because that'll mess it up.
Is in degrees. So if you're not sure how to do that, we can take a look at your calculator. There's usually a button that allows you to switch it around. But you should be looking for either a D or a DEG up at the top bar of the actual calculator on the screen. That will let you know whether or not you can actually solve this properly. Why is that? Because we're using degrees. There are other ways to measure angles outside of just degrees. That's just what we're used to, right?
Radians and gradients.
Radians and gradients. Radians are fun. Radians is a fun little world, but it's just more fractions as people are terrified of. Now, in terms of solving it, everyone's calculator is different. Everyone's preference is a little bit different. If you do work with this stuff here and you want to do an extra step and say, let's rewrite this so I actually have values. Yeah, we can rewrite this equation right here as 5 over sine 60, which is 0.866. And I want you to take at least 3 decimals if that's how you're going to go ahead and write it out. Okay? You don't have to do this step first, but if you are terrified of making some sort of mistake, then x 0.766. Okay? Now you can just cross multiply and find out what x is. Can you do the exact same thing as it is written here? Sine 50 times that divided by that guy there? For sure you can. Some people will be able to do it. You may have to use brackets. You may have to use the equal sign. You may have to do some other funky things. If you can't write this all out in one stretch in your calculator, then you'll have to add in this extra step, and then you can just go 0.766 times 5 divided by 0.866. Right? So if I do this, fine. Sine 50 times 5 divided by sine 60. And I get something like, 4 point. At this point, if you want to take it to a 10th or a 100th or a 1,000th, that'll be dependent upon what the question's asking for. Question may say rounded to the nearest 10th, rounded to the nearest, well, if we do angles, degree. Whatever they suggest is what you're going to round it to. But that is sine law in a nutshell right there, just in terms of solving for a side length. Okay? There are some other little tricks and stuff that will come into play. The only thing you'll have to notice is that if I wanted to, like, let's just say, look for this side length right here. Yeah, I won't go too crazy with this, but if I was looking for that side length right there, well, crud, I've got the 60 and 5 as my known pair, but the y is paired with an angle I don't know. I can find that angle, though, because I can go 180 minus 60 minus 50 and be left with 70. Now I can go 5 over sine 60 and then y over sine 70 and get that answer. That's the only kind of more complicated version of this that you will get. But for now, that is just like kind of like a basic intro. What I'll have you try and do on your own is just skip past all of these guys here, these are great examples that you can take a look at if you want. And just try this first guy right here. So just do one of them. You're looking for length A to C using sine law. So fantastic question here, just talking about what does the sine button do. Essentially what's happening right now is we have these like side lengths and we have degrees, right? So those two things are like worlds that don't work. Just think back to like grade 7 when you were like, tell me what 20% of $727 is. And you're like, Okay, I'm going to have to do a little bit of conversion first before I go do that, right? I'm going to have to take 20% and turn it into a decimal because it doesn't directly translate to what we're working for. Same thing here with angles. There are multiple ways for me to look at angles. Right now we're working with degrees. So we're pairing lengths and degrees together in the same formula, and it's a little bit of a different world. So nuts and bolts of it, what's it doing when you click sine? It's turning it into a ratio that makes sense. You know what I was saying? If it got bigger, right? It would get bigger if it was, right? So like if you look at it right now, if you just type in on your calculator and you just go sine 10, what does it return to you?
0.173.
Yep. So sine 10 is 0.173. So that's a tiny angle, right? Tiny little guy. If I go sine 45, right? All of a sudden I get 0.707. So sine 45, 0.707, getting bigger, right? If I go sine 85, I'm going to get, so sine 85, 0.996. And if I go sine 90, it returns me 1. So from 0 to 90, it will basically return for you any value from 0 to 1. So what it's doing is, nuts and bolts wise, it's giving you a ratio. Anything over that, sine law is a little bit weird. We'll talk about it later. It hates obtuse angles. So when it hits 1, if you put in sine 91 or sine 100, right? In fact, actually, if you put in sine 95, you know what it's going to give you? 0.996. Because it's 5 degrees away from this guy here, so it starts to go back down again. There's a little trick we can use to play with it, where essentially when we work with it now, we can do some other little tricks and things like that. But regardless, if we look at it from 0 to 90, it is essentially giving us a ratio that we can use to help us identify more about the triangle, and then use those ratios to kind of work from there. So bell's going to ring. This is going to be ending here, but I know that this here is my known pair. I would set that up here, and then this guy would solve with that. So you would have 5 over sine 72 is equal to x over sine 65, and you get 5.76?
No.
4.76? Sorry, man. What you got?
Yeah. 4.76.
Now, here's your little check. 65 was paired with this guy here. Now, I should have done this when I did that right away. Angle of 65 is paired with the x, the unknown. Angle 72 is paired with the known 5. This is a smaller angle than this guy here. If that guy's 5, he should be smaller. And proportionally so, right? It is quite close, and it is smaller. Me just hearing the 5.76, I should have clued in terms of the validation. Well, it can't be that because it cannot be larger than that one because it's paired with the smaller angle. So that's as hard as this guy gets. Get to know your calculator well, and it'll make your life a lot easier. Because you can make your life easy if you can do it all in one shot. You just do it all in one string.